let's imagine we take a string and we fix both ends on a wall and we hold it really tight. So we know that if we do this and I can pluck it on one end and I can get a wave that's going to propagate on this string or this rope. Okay, and I want to find out what speed v it's going to propagate with. Well, so if I want to do this, you can probably guess that it's going to change depending on how thick the rope is. So let's imagine we have some rope with length L. Okay, and it has mass M. And then let's say we look at a small piece of it, okay, with length dl and mass dm. Okay, we define what we call the linear density mu as m over L, which is the same thing as dm over dl. And so again, this is the linear or the mass density of the string. So the thicker the rope, the heavier each little length is going to be, and so a thicker rope is going to have a higher mass, same length, so it's going to have a higher mass density. Okay, so now I won't go into deriving it, but the basic result is that the velocity of a wave on a stretched string is equal to the tension divided by the mass density. So this is how fast a wave will propagate. And so we've calculated tensions for a lot of different systems before. This is nothing new to us. And now we're just dividing it by the mass density. And so, we can have whatever situation we want, right? We can take like a drawbridge, where we have some rope connecting to it now. We know what the tension is in that rope, and so knowing the tension in the rope, we know that if we pluck it, I can actually find out what velocity or what speed the wave is going to propagate at. And notice that that the speed is proportional to the square root of the tension. So in other words, if I raise the tension, I'm also raising the speed. So in other words, the velocity of a tight rope is going to be higher than the velocity of a loose rope. And similarly, notice that I'm dividing by the mass density. So the velocity of a heavy rope is going to be less than the velocity of a light rope. Okay? So make sure you understand this principle, because you're very likely to see a problem on the exam that's going to have to do with the velocities of waves.